Hi guys, in this unit we're going to review some properties of triangles for your final. I've started filling in a little bit of notes. I'm going to add a couple things here. There are two big triangle theorems involving circumscribed and inscribed circles. And the center of those circles we call the circumcenter and incenter. So the circumcenter, remember, is formed by perpendicular bisectors. Where those intersect each other, that point of concurrency is called the circumcenter. Here, let me say, I'm going to rewrite that. I'm going to say formed by perpendicular bisectors. Or let's actually, sorry, let's write it in a way that really makes sense. We're going to say the intersection of perpendicular bisectors. Okay, the other piece, the circumcenter is the same distance away from each vertex. That is essentially the radius of the circumscribed circle. So equidistant from vertices. All right, the incenter, so this is the inscribed circle of a triangle. This is the intersection of angle bisectors. Okay, and it, instead of being equidistant from the vertices, is equidistant from the sides of the triangle. Okay, mid-segment of a triangle is just connecting two midpoints. It kind of has two properties. It is parallel to the base and half its length. So these are parallel, and if this is x, this is 2x. So this base is double the midsegment, or the midsegment is half the base. Okay, this picture goes with the centroid. The centroid is created by medians, so it's the intersection of medians, and a median connects a vertex to a midpoint. So vertex to this side's midpoint. So all three of those intersect to form the centroid. It has this special property. So this median, once they intersect, kind of has two pieces. It's got the short piece and the long piece. So the short piece of the median is a third of the whole and half the long piece. Okay, so I guess I'll use x again. So if this is x, this is 2x, and all together would be 3x. Okay, a couple examples here. Oh, sorry, I got one last piece. The Pythagorean inequalities. So we've used this a lot. If a squared plus b squared equals c squared, we know that that works for right triangles. But we can also look at, so c just being the longest side length of a triangle, if c squared is less than a squared plus b squared, we know that it has to be acute. And if c squared is greater than a squared plus b squared, then it's an obtuse triangle. So we can also use the Pythagorean theorem to classify what kind of triangle it is. Okay, a couple examples here. First one, we're going to write the equation of a perpendicular bisector to this segment. So we have this segment. I'm just going to call it, we'll just make these A and B. Okay, so if I have A, B, A is at -2, 5. B is at 4, -1. Okay, so they want the perpendicular bisector equation. So we want the line that comes exactly through the middle, so I'm going to call that midpoint, and we want it to form a right angle. So I want the equation of this line, okay? So I need, very minimum, I need a point on this line, and I need the slope of this line. Well, the point on this line would be the midpoint. So the first thing I'm going to do is I'm going to find the midpoint. So back from our first unit, we did the midpoint formula where I add the two x's and divide by 2. So we got -2 plus 4 divided by 2. And 5 plus, and y plus y divided by 2. So we get 2 over 2, which is 1, and 4 over 2, which is 2. So the midpoint has coordinates 1, 2. Okay, the other thing I need is I need the slope of this line. Well, I don't have another point to use my slope formula on this line, but because I want it perpendicular, I know it has to be opposite reciprocal with this one. So I'm going to find the slope of this line first. So I am going to use my slope formula for that. So the slope of segment AB, y minus y, so I'm going to make this my x1, y1, x2, y2. So I've got y2 minus y1, so negative 1 minus 5, over x2 minus x1, 4 minus negative 2. Simplify, we get negative 6, add on the bottom there, so I get a slope of negative 1. Okay, so what would the slope of the perpendicular, which is this line, be? Well, perpendicular slope, remember, is opposite reciprocal. So opposite of this would be 1, and then 1 over 1 is still 1. So this is my perpendicular slope. So my equation then, I'm going to use point slope form because I know I want this slope and I want this point. So I'm going to do y minus the y coordinate, 2, equals our slope, times x minus the x coordinate. And there is the equation of this perpendicular bisector. All right, number 2, find x. Okay, so one thing, I'm going to add some markings down here, you guys. This is a mid-segment, so I'm going to add some markings so we know that. So, okay, so this is a mid-segment because those two are midpoints that are being connected. So remember, this is equal to half of the base. So 10 is equal to half 2x minus 6. And half of 2x minus 6 is x minus 3. So I can solve this for x just by adding 3 to the other side. So we get 13 for x. Okay. Okay. A triangle has lengths 8, 10, and 15. Is it acute, obtuse, or right? So 15 is my longest one. That's got to be C. So I'm going to do 15 squared, and then I'm going to do a squared plus b squared, which in this case is a squared plus 10 squared, and then I'm going to compare. So right now this is where I just like to leave a blank. I don't know if it's going to be less than, greater than, or equal to at this time. 15 squared is 225, 8 squared is 64, 10 squared is 100. If I add those, 225 is greater than 164, so if c squared is greater than a squared plus b squared, this is an obtuse triangle. All right, that's all for those examples. Thanks for watching.